Okay, Assalamualaikum and greetings to my panels and examiners. My name is Shazly bin Shamsul Fansury, and today I would like to introduce and also would like to demonstrate my first FYP for this semester. So I hope you guys have a good day today. So I will start my presentation. So my title for this throughout this whole semester that I did for almost 4 months, so is random forest classification approach for COVID-19 variants. And also I would like to thanks Dr. Izan for having me as a supervisor, and and thank you for the cooperation you made for us. So let's start off with the first chapter. So chapter one is about introduction and research problem background. So as we know that uh, the topic is about COVID-19, so we must know anything we want to make a research or a thesis or findings, we must have a problem background, and also we must have a problem statement, aims, and also objective, and so on. Something that characteristic that can bring up to the first phase of anything, of everything. So this is the first chapter that we are going to introduce is research problem and also introduction. So moving on to the introduction, so the topic that I decided is about COVID-19. So you must know a little bit about COVID-19. So here's a little touch up for you. So COVID-19 is a variant. COVID-19 variants are becoming more accessible to the masses in the whole wide country, whole wide world. COVID-19 is a respiratory ailment caused by SARS-CoV-2 virus that was first detected in December 2019 in Wuhan, China, cited by Fernandez. As we know that the research shows an in-depth evaluation of existing modern methods for machine learning and deep learning researchers, as well as explanation to how machine learning, deep learning, and also artificial intelligence might enhance the current understanding of COVID-19, as well as further research to prevent COVID-19 outbreaks. Hence, this research is proposed to use machine learning to classify COVID-19 variants. So as we know that machine learning is also evolving throughout the decades, and we know some of nowadays the trend is naive bias, and also XGBoost is the commonly one in terms of classifying and detection. So moving on to the side of the slide, you can see there's a picture shows that the all structural morphology coronavirus illustration. Yeah, this is the first illustration of COVID-19. So as we know that we as a human also want to know why, how does it become a spread such a very high demand, and also in the accuracy and also the speed can reach to global worldwide to make it like a real pandemic. So here is a clear vision, the nearest vision that we can illustrate a tiny small of like an atom, because it's hard to see in a naked eye. So we just use microscope and also something machine learning that can see beneath our eye. So this is the first structure of COVID-19. So basically, it's like we want to know how does it look, and also how does it characterize their self, so in a picture. So the next one is the figure that shows the illustration knowledge about on machine learning and also deep learning and also artificial intelligence comparison, cited by Samantha, which is an illustrated shows on the theoretically knowledge on machine learning concept. Moving on to the next is the problem background. So the problem background on the first one is COVID-19 variants, in-depth evaluation of existing modern methods of machine learning and deep learning research on overall health community, and also impact on the economic and services, which is it impact businesses, hospitality, economics, and also forcing schools and into institution to close. Due to that, most of the works that can be done at home, so they just conduct online learning and also online working. And the next one is the developing effectiveness health measures. So this one is the aim, which is basically when a pandemic hits, when a virus hits, of course we must have a cure or also a vaccine. So when the outbreaks began, we start to search for solution. So maybe in solution it comes in terms of in terms of machine, in terms of detection and classifying machine, in terms of liquid, maybe vaccine, and also something medical. So this is about the problem background. Moving on to the next is the research question, objectives, and scopes. So I just briefly explained. So the question is to achieve accurate classification on COVID variants, and also in general, it is not possible to train machine learning in-depth learning system. Moving on to the next one, next point is algorithm performance for classifying COVID-19 variants. So the objective, as you can see, mostly is about investigation on COVID-19 variants, determination prediction, evaluate accuracy of classification. On the scopes, we move to Python training and also apply XGBoost for higher accuracy adaptability. Chapter 2 is about literature review. So literature review is about comparison between machine learning concept. So machine learning concept have three: supervised learning, unsupervised, and also reinforcement. So you can see this is the comparison that I made. So for features that I collected is learning paradigm, intention machine learning, and also decision making processes. So on supervised learning, we can see the cited person, which is to develop a classification, and also to the other hand, we can see a different one, a different perspective, which is without explicit supervision, works with unlabeled data to understand within the data, and also to maximize cumulative data, involves learning via trial and in error. So you can see there's a few reduce gap between the expected reliable, predicts classifies database, previously learned correlation, and also identifies pattern, structures, or groupings in data without making explicit decisions. Moving on is the performance comparison. So performance comparison is the method, is the calculation that I use for this research, which is the confusion matrix. So the confusion matrix consists of accuracy, precision, recall, and also F1 score. So every every subtopic there's a important values in it. So which is the accuracy to measure how effective it predicts the outcomes. The precision is to statistic used to assess performance of machine learning model. Recall is to use to assess model's performance. And also F1 score is the statistic used to evaluate performance of a model. So you can see on the right side is the confusion matrix cited by Rachel. Is the image visualized briefly about how the machine tells how the machine works. So the next one is the dataset, software, and tools. So the dataset that I that I obtained is from Kaggle. So which is from Kaggle uh, is a raw data, is a raw malicious data, and it consists of 1,926 rows, and is a COVID-19 variant. COVID-19 variant dataset through ICU. So the on the right side of the image is scikit-learn, PyCharm, and also Python. So for this experiment, I selected Python, sticky library, and also accessible community. which is used by many researchers in previous studies and also the previous articles that I read. Uh, and also PyCharm is selected to for familiarity of use in JetBrains based on IDE. So it's a basically is a common thing others uh, like others classification model. Okay, moving on to the next one is the chapter 3. So the chapter 3 is about methodology. So methodology, this is the research framework that I made. As you can see, the first the three phases, which is phase one is identification of dataset feature selection to train machine learning algorithm. The phase two is development of COVID-19 variant and classification model, and the next one is performance comparison of trained learning models. So on each phases, it has a important message and also briefly explanation why is it important. So these are the importance that I made. So on the chapter 4, is about research experiment, the experiment that I did for this research, and also this is the research flowchart. So in the research flowchart, you can see there's a vision, there's a start from start until the end. So you can see data process uh, goes down to feature selection and then to algorithm selection. So in algorithm selection, I selected two, which is nine bias and also XGBoost. The two machine learning that I choose as a comparison to make this research work is a cooperative. And then we go down to the testing and also evaluate. And if the answer is okay, then if yes, then it goes down to the develop classifier to take the performance comparison. And if no, it will parameter tuning start from the phases that might be the occurrence might be error debugging. So this is the workflow, research workflow. So the phase one on each phases from the subsequent of the flowchart. Phase one is planning and preliminary research. It goes down to phase two, research data preparation. Moving on to the phase three, classification process using proposed method. And to the last phase, phase four, research evaluation. So this is the workflow and this is the milestone that I achieved on this FYP. And so on the left one is impute coding, which is to handle missing values to the pre-processing. So this is the data pre-processing that I made. On the right side is the code snippet performed for feature selection, which I use for three classifier on this proposal, and it is a partially code for phase two. So chapter 5 is the result analysis and discussion. So I would like to I would like to give a huge respect and also highly honored to my supervisors, colleagues, and friends for helping me. And also, I would like to thank you, my examiners, for listening to my video presentation. So the milestone that I've gained is algorithm that I've decided is 9 bias and SG both, and the data set that I've chosen is relevant and also I can use it, which is the Kegel serial Lebanese ICU prediction obtained from the Kegel. And then also the performance parameters are selected, which is the performance in the confusion metrics, which I use. And hoping for the next FYP2, I will conductly finish the whole research. And I was hoping for a good findings in the end with a with the flying colors. So that's all for today. Thank you so much and see you next time.